All right. So today we're talking about the domain and the range of a linear application. The domain and the range of a linear application. Someone tell me what the I can statement is. What is the I can statement for lesson 3.6? What is the I can statement? So that should be at the very beginning of your Unit 3 journal. What is the I can statement? Go ahead, Aiden. You didn't get the I can statements? Someone else, tell me what you got for the I can statement. Nobody has their I can statements? I know I passed them out to all of you guys. Yes, I did. Go look. I can statements, Unit 3. It's a green piece of paper. It says Unit 3, linear functions. Unit 3, linear functions. Right there. Huh? Yeah, I know. Yeah, she did. She said that your journal was a mess. You haven't include anything and just shove it in the bag. She emailed me. Okay, you don't have your you don't have your Unit 3 I can statements.
I can't identify the appropriate domain and range for linear function in context to predict value for one
Say it louder. I can identify what?
an appropriate domain and range for a linear function in context to predict value for linear.
Yeah, I do. I can identify an appropriate domain and range for a linear function in context and predict values based on a linear scenario. It is a green piece of paper. It's a half sheet of green paper. You have got to start gluing your stuff in your journal, especially when you're absent. Look at that. Look at this. 3.1. You need to fill that out. This is 3.2. You need to fill that out. Isaac, you need to get it together. You're not doing your stuff. Where's your folder? You see it? I'll read it again. I can identify an appropriate domain and range. I can identify an appropriate domain and range for a linear function in context. And I can predict the values based on, I know that I had it paper clip with all your other stuff. And you're missing. So when you got this filled out thing right here, it was with that. This is the filled out thing. This is my copy. Does that make sense? So you don't have a half sheet of green paper anymore? Okay. I'll have to print you a new one because I can't find it right this second. Okay. So I can identify an appropriate domain and range for a linear function in context. Yes. It should be at the beginning. Remember we talked about skipping a page? Yeah. I can identify an appropriate domain and range and, oh, sorry, for a linear function. Are you writing this down in your journal or are you not with me yet? Right here. For a linear function in context and predict values based on a linear scenario. And predict values based on a linear scenario. Tyler, come back here and stand by me. We're not sleeping in class. Bring your journal back here and just come and stand. Thank you. Someone tell me what the domain is. Domain. You should know, go through your journal. You should absolutely know what it means when I say domain. We've done this for 2 units now. Domain. What is the domain? Owen?
It's I know it. I just
X value.
It's the X values. Your domain is the X values. Your domain is the X values. They're also called the input values. Okay. What is the range? Lissandro, come up here and stand. What is the range? They're the Y values. They're also known as the output. He can sit on the tall table. He just isn't sleeping. We're not doing that. Okay. It's your output values. It's your output values. All right. So a warehouse is keeping track of its inventory of cardboard boxes. At the beginning of the month, they had a supply of 1,275. The beginning value is 1,275. When I think of a linear function, the beginning value where we begin is represented by what?
the slope.
That's your rate. When I think of a linear function, like y equals mx plus b, the beginning value is represented by what?
By m.
No, m is your slope. That was your first guess. M is your slope. Yes, it's represented by b. Remember that b is where you begin. This is where you begin on the y-axis. It's known as the y-intercept. We call this the y-intercept. I think that's important. I think you should write that down. If you guys don't know that when you see the word beginning, starting, that's telling you what your b value is, then you should write that down. It's very important. So we know that b equals 1,275. We're using boxes at a rate. Look at that word, rate. That means my slope. We're using boxes at a rate of 75 per day. So my slope is going to be 75. So Daniel, what is an equation in the form y equals mx plus b of this word problem? Ken, help him out.
Y equals 75 days. Plus something.
Just say the numbers. Plus what?
1.
What is b?
1275.
So of 1,275. Okay. So y equals 75x plus 1,275. It says consider the domain. So we're giving you a domain below. Do you see? It says consider the domain of the function below. Which values do not belong and why? Well, what does x, my input value, represent? What does this represent? What number am I inputting? What does x represent? It's my domain, but what does it stand for in context of this problem? The number of boxes that we have left is y. That's my output. Boxes left. What does x, what would we, the number of days. So x is the number of days. You can have this chair if you need it. We're just not sleeping, okay? If you need this chair, you can. X is the number of days. So, what would be some values in that domain that don't make sense? 3.2. What do 3.2 days look like? It's not a whole day. It's 72 hours plus something, right? We're talking about per day, so we want whole days. Okay. What else looks weird? -1. Yeah. What does it look like to time travel, right? Can we have negative days? No, we can't. We don't go back in time. So those are the two values that don't work. Why? Well, we can't have negatives and we can't have decimals. So I'm going to actually write a little note here that says our domain must be positive integers. Right? Integers are whole numbers, positive and negative, right? So we just need to have positive integers. Okay. So the second question says, well, is 325 an appropriate range value? Meaning, can you have 325 boxes? So let's think about that. Y equals 75x plus 1,275. If my range value, which is my y, is the number of boxes that I have left. Y is the number of boxes I have left. How would I plug that in to see if that's appropriate? This is saying, is 325 an appropriate range value? How would I plug that in to my equation to check it? How would I substitute that value in? What is 325 asking me about? Is it asking me about an input or an output value? An output. And y is our output. So I'm going to replace the letter y in my equation with 325. And I'm going to solve to see what my input value is. I'm going to solve to see what my input value is. So how would I solve? Ooh, I have a question really fast. Are we adding boxes to our pile or are we using boxes? We're using. So what does our slope need to be? Yeah, this slope needs to be negative. Do you guys see that? Your slope needs to be negative. So up at that top where it says equation,